All right, what I have today are some sample tags from a customer. These are things that were printed on the Brady print system using our Bartender templates. And this one's kind of interesting in that it's a flag tag. These are tags that have two printable sides. And if you look at the back side here, hopefully the glare's not too bad. I'll have to make sure I plan around that. You've got your chip and antenna on one half, and then nothing on the backside. But the idea is that you print then on both sides, and then as you peel it off the backing paper, you fold it along this line, you know, fold that under, and then this on this side is sticky, and you can just place that on a metal surface that would otherwise ground out a standard tag. You can just let it flap in the breeze, hence the name flag tag, right? That allows you to use these less expensive standard tags without the um, foam isolator that are in Brady's alloy tags. Okay, so we have 5 tags, and I'm going to validate whether or not these conform to the ATA spec if they were made properly with the Brady template that I provided. And we do that using a program called Brady Tag Assistant. I'm going to make this a little bit smaller so you can maybe keep the camera up at the same time that I'm doing this. Okay, Brady Tag Assistant is using this TSL 1128 reader. It has an integrated barcode scanner as well, and this model does. And it's tethered with an USB cable to my PC. Now, I could use a Bluetooth connection as well. Either one works. But that uses a virtual COM driver from FTDI. Pretty standard stuff, been out there for 20 years. And you have to pick your proper COM port. In this case, I just happen to know that when you plug this in, it becomes COM3 on my system. So I'll hit connect. And just to verify that I am connected to this reader with COM3, it says serial number here, and that is listed on the bottom, or rather on the top of the reader itself. I'm going to see if I can turn my LED on a little bit. Hang on. There we go. Is that better or worse? Can't really tell. I can't really tell. So we start with just putting your reader someplace near, and if you hit find on the button here, or you pull on the trigger, I'll just pull on the trigger, you'll see that I get all 5 tags because my power level for this reader is set up pretty high, right? And if you really wanted to isolate that, you can do it in 2 different ways. One, you can just notice here what we call the URN format of the EPC bank. This will show the filter code, which is emergency equipment, cage code, then nothing, 2 dots, and serial number. You can just match the printed serial number on the tag with what's here to figure out which one's which. The other way to do this is to just crank the power down by hitting that little cog wheel to get into setup. Now let's just crank it down to something really low, like, I don't know, 13, and say okay, and you have to reconnect, hit find, and now I only get 2. So that's another way you can isolate, really crank this down. Doesn't really matter in the end. I think it's totally fine, in my opinion, to just go ahead and keep your power up high, especially if you're doing the alloy tags. They can be a little bit harder to read if they're not on a metal surface. So, just go ahead and throw it up there as high as you can. Find only ATA tags. This is a good idea to check this because it will then filter out anything from any other type of industry. You'll only see the things that begin with 3 Bravo. And I'm not going to check these. We'll come back to that in just a second. 2 things aren't going to happen here. I have a configuration file that's already here that comes with the program, and it's editable. So as you get new chips on the market, you can go ahead and edit that, add new chip architecture here, and you can use this same software to support tags that haven't even been created yet. It's a huge, huge future-proofing advantage of this software. I don't really know anybody who's got anything other than this software. This is the only validation tool I know of anyway. So, all right, so we'll pick these. Notice I picked up something else in my vicinity here. And I'm now going to pick, let's say, I'm going to look here and I'm going to say, okay, this one has a serial number of ending in 699, so I'll pick that one. I'll put my reader right on top of it, right? 699. And as it's highlighted, it'll show you the EPC value, cage code, again, no part number for this one, in the EPC value. And because they're serializing uniquely within their cage, right? And then the filter code of 19, shown over here, means other emergency equipment. All right, so I'm going to go ahead and hit read and validate. And very quickly, it's going to go ahead and validate that the data in the tag is structured properly for a Spec 2000 version 2016 dual record format. Okay, so you'll see a green indicator here that I've got a birth record and a life cycle record, and a green on the tag which says I have a chip. This is the model number of the chip, the manufacturer of the chip. This is the size of the chip, 128 words, right? So everything I need here is, I already validated green, green. That's really what you're looking for. Here are the contents in the life cycle record. Here are the contents in the birth record, right? And they do conform to the ATA spec, except for this little note here. It says user bank locking was not verified. Now, this is a huge difference between using a mobile reader, which is only going to read a tag. It's not going to validate that the tag is properly secured. And that's a huge part of any ATA tag. So that's why this software should be used for QC purposes rather than a mobile reader with just reader mobile app, right? So if I'm going to go back into my settings cog and I'm going to check these items, validate user bank locking and display the lock details. Click OK. Connect again. Find my tag here, 699. And when I do read and validate this time, it's going to take a lot longer. It'll take, it's going to check each one of the words to find out, are you locked and should you be locked? Because the birth record is supposed to be locked, right? But the life cycle record is supposed to be open and rewritable. So that boundary of where is the birth record and where is the life cycle record is not a set in stone location on the tag. There's no spec requirement for where that is. So it kind of has to go through each one of the words on here and check, are you locked? Should you be locked, right? And now you've seen that that warning has gone away. And we have, in fact, validated the, see that kill and access password checks past validation. That's the password bank. And then there's no other warning. So it has checked the locking status for each word, and that seems to have worked okay as well. We can now, because we have a green check here, we can hit verify. And what that does is it takes those results and appends them to a CSV file that contains all of this validation record stuff. So if I go to that folder where that is located, it's here, and I'll see this is the log file results, and you'll see that I have something here on the 5th of July that just got added, and it's just a CSV file with the output results of all of this. Now, ID integration does supply a browser widget that can make this more presentable in a grid, in a table that you can print as a PDF file and save if you want. But from Brady anyway, this is your results file. Not terribly glorious, but again, this is the industry's only true validation tool that I know of, okay? All right, so we're not quite done, because there's another thing you can do with this software, and that is to validate that the barcode data, you know, you've got a barcode here. Do the contents of this barcode match the contents of the chip? Kind of important. And it's not all that uncommon that people will set up a printer incorrectly and they'll encode the chip behind the one that they're printing if you're not careful, right? So we can validate that by clicking on barcode verification, right? This is our tag. And you have two different ways in which the barcode can be structured. The military way, the DoD way, and NATO, all NATO countries conform to the same standard here. This is the old UID standard if you're familiar with the military world, and the ATA standard, which is the original slash delimited structure of a barcode. Airbus is probably more likely to use the ATA from my perspective, but you really need to look at your contract and see which one you're supposed to be using. All right, so put your cursor in this position, and I'm going to take this. One nice thing about the TSL 1128 is if you take the trigger and you hold it, you get a read. If you go click hold, you'll get a targeter. You can't see that very well, but it's an X. So you can see it on my hand a little bit better. And that's what we're going to use here. We're going to click hold. We'll grab that data in that barcode, right? And you can see that we've got this slash delimiter in between the different data segments. Here's the cage code, here's the serial number, there's the current part number, and they got data manufacturer. Now, this is very, very important. When I hit parse here, you're going to see it's going to look at each one of those values, and it's going to say what was actually in the chip. It says record data, that means the chip, right? This is the barcode contents. And notice that in the date of manufacture section, the value in the chip is not the same as the value in the barcode. And that is okay because the ATA spec does barcode and chip differently. And the software here isn't able to really truly understand that. It just highlights it in yellow. But it's an 8-digit value in the chip. It's a 6-digit value in the barcode. Month, month, year, 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 year. Whereas this is year, 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 month, month, date, date. Okay. So this is good. We can hit verify. And guess what? Yes, there is another barcode log file where that stuff will get listed, right? You can see these are ones up here, previous tests that use the DoD format, and these are ones that use the ATA format, okay? So your results file produced by this are two results files. There's the log file for the RFID chip data validation, and then there's a barcode log file for your barcode data validation, okay? This is your rules file or configuration file for the overall program. So that's really how this works in terms of the Brady program. You go through each one of these files. You can do another one really quick here. Let's do 698, which is the one that's just before it. I'll change my, oops, should have put my camera on so you can see I'm going to the next one down here now, right? And I've highlighted 698, hit, and this comes up automatically. Notice it changes as I click once, right? Now 698, I'm going to hit read and validate. It's going to do the same thing. It's going to check the locking status as well as the data values and hopefully give us a green light for both the birth record and life cycle record. You don't have to verify and save these things to a log file if you don't want to. Totally up to your choice of documentation. But when it's done, you really want to look for green, green on everything. And I would highly recommend that you follow through with this longer security locking step. It's probably one of the most common errors in ATA tags. Okay. All right, so we're good here. Again, you can hit verify, goes to the record, and you're done. And that's really how this works. I'm going to go ahead and do this for this customer on these remaining 3 items just to make sure everything's fine. But again, it looks like they're all totally valid, and I can send them the verification files as well. One last mark here was if you do want to change the barcode style in the templates that are supplied by ID integration here, if you want to change the style to the DoD format, that's controlled by the defaults form that we generally include that most people skip past. You know, on the primary form that comes up when you go to print, we'll have a little checkbox for admin. If you check it, you can go in and look at all and change all the defaults for other things. In this case, it's a dual record with the timestamp, 6-bit encoding, blah, 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 all this stuff. Here, NATO style barcode. If you check this, it will then use the DoD format. And it's just that simple in terms of whether you want your templates to use the ATA standard, the original ATA standard, or the DoD standard, which again is perfectly acceptable to the ATA world. They also accept the military uh, structure for these barcodes. If you're making products for both military customers and commercial customers, that's probably the right way to go, so long as your contract for your commercial stuff allows you to do that. So, all right, so there's a quick overview of Tag Assistant. I hope you enjoyed it. Again, highly recommend this for all QC tasks related to ATA tag production. Mobile readers and mobile apps will not validate the locking component of this. And in addition, there are certain apps that will actually read data that's got errors. It may have syntax errors, but the reader says, well, this is what's in there. It's not telling you that it's correct. This program tells you it's correct.